Very good afternoon. Welcome to the live virtual classes organized by the Board of Studies Academic. Today, we are taking up statistics, the first chapter of statistics, which involves the description of data, the statistical description of data, and the second unit is on sampling. So I welcome all the students in this platform, and we are commencing with the first chapter of statistics as part of the quantitative aptitude paper. There are two units. This is chapter 13 of the ICAI study material. There are two units. Unit 1, which addresses and covers the entire gamut of statistical description of data. And in the second unit, we have sampling, the sampling techniques, principles, of course, applications. So we first start with the introduction to statistics, because we have number of chapters in statistics which are very interesting as well as highly practical in your journey. In order to become a chartered accountant, you will find the application of statistics almost in every paper which you study. So when we look at the applications, you see this is the unit 1 of chapter 13, statistical description of data. So the intention or the learning objectives of this particular chapter is to understand what is statistics and the different applications. Secondly, we must be aware about what is data. And we all know, we all hear about data, as we say that data is the new oil. But in statistics, we have different techniques of data collection, and we will learn primary, secondary data. The third learning objective is to understand how to present the data. So once we have a broad overview of what is statistics and the applications, we shall move on to understand the distinction, what is primary data, what is secondary data, and then we shall learn how to present the data in different forms. It can be in tabular form or it can be in diagrammatic form. So we will look at some of the important practical principles. And of course, we have frequency distribution and so on. So these are the immediate learning objectives. And we will also become familiar with the structure of histogram. Of course, first we have line diagrams and then histogram, frequency, polygon, pie chart, and ogive. So these are important statistical tools of representing data. So first we look at the applications. So what is statistics? And why are we studying statistics? So every organization needs to take decisions, and the science of decision making starts with the process of collecting data. So a company, say for example, wants to cut down its cost. So the company needs to understand and collect data about its different types of cost, the fixed cost, the variable cost, the raw material cost, overheads. Of course, different items of cost sheet. And then it needs to analyze which type of data is increasing over the last few years. Which type of cost is controllable, to what extent. That means behind every successful business decision, there's a long process of collecting data, organizing the data, presenting, analyzing the data, and from there, interpretation of the data. So this long chain of data collection, organizing, sorting out the data, analyzing the data, presenting the data in a meaningful manner, and then taking time to interpret the results. This can be said to be the process we follow in statistics. So statistical analysis is used to first clean sort the data, summarize the data, and therefore statistics is an objective scientific procedure for making effective decisions. And dear students, you all will definitely agree that in today's dynamic, volatile, uncertain business world, decision making is of paramount importance, and this can be the difference between success and failure. That means if any individual, a company, any organization, if we are able to take a right decision at the right point of time, then we get success. Otherwise, we face a lot of challenge. So therefore, statistics deals a lot of chapters of statistics. You will find it deals with different type of data. So therefore, all of you are aware about a particular term which is called data science. Even if you look at artificial intelligence, machine learning, it deals with a different type of data. Now, AI systems are able to predict different outcomes. It can provide prognosis. It can generate a lot of documents, a lot of information, a lot of results. Plus, you are aware about agentic AI. So all the AI tools and the entire ecosystem deals and analyzes data. Whatever career you choose after becoming a CA, regardless, even outside the domain of chartered accountancy, every other profession, just like ours, readily and heavily deals with data. So whichever professional decision you are making, it has to handle data. So data handling, data analysis, and presenting the data is a core skill behind every successful business decision. So statistics is the science of data collection, data sorting, analysis, interpretation, and presentation. Right? I hope you are able to understand the core concept of statistics. So there are two types of statistics, as is also mentioned in the study material of our institute. So first is descriptive. That means here the intention is to use a lot of graphs, tables, numerical calculations, and it deals a lot with description of the entire data set. The second type of, or the second branch of statistics is inferential. What is inferential? The word inference means conclusion. What is the inference I draw? That means what is the conclusion I draw? What is the outcome? What is the result? So inferential statistics deals with population. From the entire population, understanding and dealing with different samples, statistics is able to provide certain predictions, inferences. For example, there is a particular chapter in statistics which is called correlation regression. We will deal with this chapter later. We will understand the different principles of correlation regression. So this particular tool of statistics, correlation and regression, this helps in business forecasting, in predicting sales. You have different other very interesting chapters like index number, which is there in our curriculum in CA Foundation. And you will understand the practical applications of index number in statistics, of course, in economics, in stock markets, everywhere. And therefore, statistics has two parts. First is descriptive, the other is inferential. Both are equally important, of course. Together, the descriptive part and the inferential part together makes statistics a highly practical and a very relevant business analysis tool. And to a large extent, the AI ecosystem, the AI tools, heavily depends on statistical concept. So without understanding statistics, it is very difficult to understand forecasting, prediction, analytics, and AI. So the base or the foundation is statistics. So now we see what are the important characteristics. the features of statistics. So statistics, number one, is numerically expressed. So that means the subject entirely handles data, numbers, percentage, ratios, and so on. The data will be collected in a systematic order. And the importance of data analytics is to compare the data of one year with that of the other year. For example, say we want to compare the sales of one company with other companies in the same year in the same industry. So maybe it's a real estate company, let us call it X, and we want to compare the trend in the sales of X with other companies in the same industry, maybe in the last 3 years. So this can be termed as inter-firm comparison, and we can use a number of practical statistical tools. But the intention is to compare. Comparing the performance of one company X with the performance of other companies in the same industry. We could also compare the sales, the costing structure, the EBITDA, that is the earnings before interest, tax, depreciation, amortization, the profit after tax, the share price of one company with its own performance maybe in the preceding year. So this is intra-firm comparison. Within the same organization, we are trying to compare the performance. So therefore, statistics entirely handles comparison of data, and the data is collected with a planned purpose. So entire subject of statistics is purpose-driven, data-driven, and therefore it is highly analytical and mathematical, of course. So different tools are there. For example, central tendency, dispersion, probability. These are different tools, chapters of our curriculum. And you will find as and when we discuss each of the chapter, you will realize how important this particular subject is in the world of business, economics, finance, accounting, and so on. So this is the important, these are the features of statistics. So if we look at the study material, once again, the definition of statistics is given. Once again, please see, statistics when used as a plural noun may be defined as data, qualitative as well as quantitative, that are collected usually with a view of having statistical analysis. That means data collection, sorting, analysis, and thereafter presentation. Okay, if we now move to the next slide and we see the unit overview from the study material, you can see the application of statistics, which covers the collection of data. And then you can see in the table the presentation of the data in the textual form through text and in tabular form, that is through table. And the third way is to present data graphically through diagrams. So it could be a line chart, a frequency polygon, and so on. So we shall look into each of these applications, and the data in statistics are of two types. So in the exam, when we look at the important questions from the exercise 13, and thereafter we shall move on to discuss the solution of some of the important questions from the MTP, the RTP, and the past year's questions, you will find that several questions from this chapter are on the theoretical part. So all questions need not be based on calculations. Some questions could be based on the theoretical, the technical part, and the principles. So please study the entire chapter, all the paragraphs, because there could be some theory questions which are equally important. And this theory actually serves as the foundation. Even in accounting, before doing any numericals, we first have to understand the theory, the journal entries, the ledger, and then we complete final accounts. You actually draw a balance sheet, profit and loss, and so on. So theory is very important in statistics. more because number of chapters in statistics, these are based on the foundational concept of data, right? So therefore, please go through each and every point like we are analyzing and discussing both the theoretical part, and very soon we shall move on to the numerical part as well. So data are of two types, primary and secondary data. So when the data, what is primary data? So these are collected for the purpose of analysis. Secondary data means the data which is already collected. Say, for example, the annual production of, say, any particular agricultural commodity, say rice production in India. So when the government of India, when they try to capture the information regarding the annual production of rice across the country for the purpose of decision making, for the purpose of understanding our productivity, well, that could be seen as an example of primary data because the data is collected specifically for a particular analysis. But once the government has obtained the data and maybe they have published the data, compiled the data in the website, and maybe you as a researcher, you are doing research, you are downloading that data from the government website, and maybe you are doing some analysis, you are using the data for a project, maybe in your college. Well, this data becomes secondary. So I hope you are able to understand the distinction between what is primary, what is secondary data. Then we have what is variable and constant. You know, a constant always has a fixed value, but a variable, for example, height, weight, temperature, humidity, pressure, sales, right? Every figure we deal with, these are all variable because these will vary over time. These will not remain the same. But you know, in mathematics, we have certain constants, like if I say pi. Okay, the pi, you know, when you draw the circumference, when you want to find out the length of the circumference of a circle circumference, 2 pi r. This pi is constant. You know, pi has a value of 22/7. It is a constant. Similarly, in statistics, we shall see later there is another constant called E, which is called Euler's constant. So constant has a fixed value, whereas a variable will change its value on different occasions in different time zones, time frames. So therefore, I was mentioning, and we were talking about the application of statistics, marketing, finance, human resource, n number of applications, which makes statistics a highly practical paper. So correlation, index number, time series, I was mentioning each of them in the earlier part of the discussion. Similarly, when in marketing, in human resource, operational management, there are so many important applications of statistics like deviation, standard deviation, variance. Even when you go to capital market, investment banking, international finance, economics, both micro and macro, you will find a tremendous importance of statistics. So these are the overall applications, and we have looked into the types of, some numbers are variable, some numbers are constant. Of course, we have primary data, secondary data, plus data could be of two further types. It could be observations which fall under qualitative parameter. Qualitative, that means it cannot be expressed through numbers. For example, the hair color, the ethnicity, religion, country, which state you stay, which city you belong to, which college have you studied. These are also data. These are also information, but these are qualitative. On the other hand, quantitative data means these could be measured on a numerical scale. For example, percentage of marks, or say the number of children in a family, the distance which you travel every day to reach your college, the temperature on a particular day. So these are quantitative data, right? So I hope you're able to understand this is the foundation of statistics unit 1 of chapter 13. In the unit 1, we are covering first the basic understanding the concept of statistics. What is the objective of studying statistics, the relevance of statistics in CA, in the chartered accountancy course, and in other professions as well, including marketing, of course, finance we have discussed, marketing, operations, human resource, every sector. Okay. So the application from the study material, if you see economics, right? So whatever we were discussing, you can see is so important because in the study material of the ICAI, separately chapters in this particular chapter, there are separate paragraphs to highlight the applications of statistics in the field of economics. And you can see some important reference given to index number, demand supply analysis, time series data, the use of regression analysis. Business management, yes, we always use the word strategy. Today, organizations are able to survive only when they adopt the right strategy at the right time. Strategic management is part of your CA curriculum. In intermediate, you have 50 marks paper on strategic management. But you will find in due course, as we go ahead with each and every chapter, that the world of business management, strategic management, depends on a lot of analysis, numerical analysis, quantitative analysis, and many of the tools are based on statistical concepts. Similarly, in the study material, you can see the next paragraph, the application of statistics in commerce and industry, where some of the important chapters include correlation regression, central tendency, that is average. You are aware about mean, average. So you have arithmetic mean, geometric mean, harmonic mean, median, mode. Plus we have an important chapter on dispersion, where we look at variance, standard deviation, mean deviation. So all these are of practical importance in the world of commerce and industry. So you can see on the right-hand side of this slide, dear students, you can see the type of variables I was discussing. So there could be two types of numerical data. One could be constant, one is variable. Statistics deals a lot with variables. And variables, again, we see are of two types. It could be seen as qualitative and quantitative. So qualitative could be something like, say, dichotomic and polynomic, like marital status, usually married, unmarried, assuming two types of marital status. So it could be dichotomic. Gender, male, female, assuming two types of gender, it's a dichotomic data. Then you have polynomic, that means more than two. Hair color, the brand of your laptop, the brand of your smartphone, the brand of your car, these are all polynomic. These are data, information, but qualitative and polynomic. Then we have quantitative data, which has two types, two further divisions. One you can see is discrete. That means certain data which can occupy specific numbers, maybe whole numbers, maybe positive numbers. For example, the number of children in a family cannot be fractional. It cannot be negative. So it's a discrete. It can occupy specific values only. On the other hand, the profit of a company made in a particular year, it could be positive, it could be negative. When the profit is negative, we use the term loss. The profit can be a whole number, it can be a fraction as well. Similarly, the temperature on a particular day can assume any number, any figure. It could be fractional, it could be negative, it could be positive. The weight of a student, the height of a student, So any parameter we are talking about, physical parameters, the weight of a student, the height of a student, so these are essentially positive, and it can occupy any particular number. It can be fraction as well. So it is a continuous data. Okay, so you can see the different types. So data जो है variable, constant, first difference. Then we have the next type of, when you talk about variables, it could be qualitative or it could be quantitative. Qualitative has two further divisions, dichotomic, polynomic, and quantitative has two different types. We have discrete. That means those data where the numbers, the value the data can take is specific values. Continuous means it can take any value within a given interval, including negative. It could be fractional as well. Finally, in this particular part, we have limitations of statistics, and the study material deals with the fact that statistics is more focused with quantitative data. Plus, whenever statisticians use the tools of statistics for predicting or projecting sales, demand, even the share market, the stock market index. So these are based on assumptions, these are based on specific conditions, and these predictions are based on particular assumptions and ground level facts. If there is any change in the condition, in the assumptions, the projection, the prediction will also change. So therefore, that is another limitation of statistics. And of course, the field of statistics deals a lot and built upon random sampling. So if random sampling is not followed, of course, the results could be a little unexpected. It could be erroneous, wrong as well. So these are the important limitations of statistics which you need to go through and understand. The next slide we move on. So this slide I would summarize with this particular thought, that statistics helps any organization to frame their strategy and data to decision. That is the journey through the use of data analytics, through the use of machine learning, deep learning, AI. The ultimate objective is decision making, and that is heavily influenced by data. And statistics is entirely concerned with the collection of data, the analysis of data, the interpretation and presentation of data. So I'm sure you're following each of these important concepts which we are discussing. And I'm trying to explain the applications of statistics in today's business environment with a special focus on the chartered accountancy curriculum. Now we will look at the collection process of data. So as we were mentioning, the data can be of two types, primary and secondary. So primary data is when the data is collected for the first time for the intended purpose. So the data which is collected for the first time by an investigator, by an agency, by a ministry of the government, by an organization, is known as primary data. So there's an example given in the study material. If Professor Das collects the data on the height of every student in his class, so it could be a primary data for him. However, if another professor, say Professor Bhargava, is using this data, which was originally collected by Professor Das. So Professor Bhargava is using this data, which was originally captured, collected by Professor Das, but Professor Bhargava is using this data for finding the average height of the students. So therefore, this data would be secondary data for Professor Bhargava, whereas it is a primary data for Professor Das. So very well explained in the study material. Then we have the collection of primary data. So what are the different processes, methods for collecting the primary data? So dear students, I hope you are now very clear about data, qualitative, quantitative data, primary and secondary data. So now we proceed to discuss about the different tools. And many of the important concepts which we are explaining one by one along with examples, please study them as well as possible, because few questions could come even on the theoretical part, as I said earlier. So the collection of primary data, interview methods. So you could talk to different people to get their views. Now, a very simple example is review. So you go to a restaurant with your family, or you go and watch a movie. Sometimes we have to give feedback, feedback. We have to provide a feedback. So the salesperson may come, the marketing person may come and say that, sir, ma'am, can you give your feedback, specific feedback on a scale of 1 to 10? So when you say you give a feedback of 8 out of 10, so it could mean good, very good. So 8 out of 10, this is a quantitative data. But sometimes a hotel or a restaurant may ask you to give a feedback, and the feedback might be based on 3 classes: average, good, excellent. So these 3 words, average, good, excellent, these are qualitative data, but they can be converted to quantitative data, but these are essentially non-numeric. There is no numbers involved. These are subjective, a little subjective, or qualitative data, we can call it. So we have the interview method, which includes personal interview, indirect interview, telephonic, or nowadays, of course, online, virtual interviews could be conducted on a personal basis in order to get information and data. Telephonic interview is usually seen as non-expensive, quick, plus we have important tools like mailed questionnaire methods, and of course, different forms of questionnaires are sent, usually over email. Sometimes it could be the post as well, but usually over email, over WhatsApp, over messaging. And sometimes data can be collected through observation as well. So interview method, mailed questionnaires, observation, direct observation, and questionnaires filled and sent by enumerators. So there are 4 principal ways of collecting the primary data. Please remember each of these points carefully so that if a question comes, you would be able to respond correctly and come to the correct conclusion. Now we look at the secondary data. What are the sources of secondary data? So we saw the different 4 methods of getting the primary data. Now, what are the sources of secondary data? So it could be international agency. If you see the website, if you visit the web page of any of these organizations, international organizations, entities like the World Bank or the International Monetary Fund, the International Labour Organization, or the World Health Organization, the United Nations, for example, you get to see a number of data set. Several government sources. I was mentioning an example about agricultural productivity. So the Ministry of Food and Agriculture, they will collect a lot of data. Different private and government sources, including quasi-government sources, they publish a lot of secondary data. So these are the different sources of secondary data. And now we proceed to discuss about what is density of data. So density of data means the population divided by the area. So if I say that there are 2 cities, 2 metro cities of the same size, but maybe from the first city, I have got 10,000 citizens who have given their responses, and say the area of the city is 100 square miles or square kilometer. 10,000 citizens of particular city A has given their responses to a questionnaire, or to I have sent an email to 10,000 people, they have responded with their views, with their feedback. So that means the area of the city is, say, geographical area, say it is 100 square kilometers, but I have received 10,000 responses. 10,000 individuals, people have sent their feedback. So I can say the density is 10,000 divided by 100. That means 100 responses per square kilometer. That is the density of data. In another city, maybe city B, I have received 20,000 responses. And the city maybe has the same area. So maybe it has an area of the same area, 100 square kilometers, 100 kilometers square. Now here the density becomes 200. So I can say that the data density in the second city, city B, is better, it's higher, because in city A, I was getting a density of 100. In case of city B, it is 200. So therefore, the population divided by the area, it can be a measure of density of data. Now we see we discuss a very important point, and several questions have come from this particular portion of Unit 1 of Chapter 13, and that is the classification or the organization of data. So what are the four methods of classifying the data? So it could be first time series data or chronological. Chronological means, say, year-wise, month-wise, daily data, quarterly data. That means it is based on time series. Along with the passage of time, the data will change. For example, the temperature of every day, the rainfall in a city every day during the monsoon, the sales of a company every month, the profit of an organization every quarter. So this is time series. Second, we have the geographical or spatial series data. So time series, you see even simple examples in the study material of the ICAI. So simple and practical. Please see the number of students appearing in CA final for the last 10 years, 15 years, 20 years. So this is specifically a type of chronological or time series based data. Geographical data. CA foundation students who are appearing for the exam in September 2026. There will be thousands of students. These thousands of students will be from all across the country. So if I divide all these students into 5 regions, northern regions, western, southern, eastern, and central, what I will get is geographical or spatial series data. If I try to capture the data, these, say, 10,000, 20,000, whatever number, the number of students appearing for CA Foundation in September 2026, if I want to view the data, if I want to see the data based on the different states and union territories of our country, that means how many students are appearing from Rajasthan, how many students are appearing from Tamil Nadu, how many students are appearing from Delhi. So this gives me state-wise and union territory-wise the number of students who are appearing for the CA Foundation. So this is yet another example of geographical or spatial series data. Okay, I hope it is clear, you are able to understand. The third, we have qualitative data. So very simple example from the study material: nationality, gender, religion, eating habit, what type of food you like, your food preference, which one is your, say, for example, if I ask you that, okay, which is your favorite subject, which paper is most interesting for you. So this could be an example of qualitative data. And quantitative data, as we were discussing earlier: height, weight, salary, temperature, pressure, profit, revenue, whatever, cost. So these are quantitative data. Okay, so these are very simple but essential elements of Unit 1 of Chapter 13. So I hope you're there, you're following, you're understanding. So we looked at the classification. Now we see, so 4 methods of classification, please do not forget. Now, the mode of presentation. How do I present the data? So our next few slides of this chapter will be based on particular presentation of data. So here we see 3 methods are there, and if you see, there are 3 methods: textual, tabular, or through a table, and the third is diagrammatic representation. Many of you, dear students, during in your college or in your high school, your plus 2, when you appeared for the plus 2, the board exams, many of you may have studied statistics, and you must have come across graphs like diagrams like bar graphs and histograms, line diagrams, pie chart. So these are diagrammatic representation, and table based data we all have been studying right from high school. So we know that these 3 types of data. So textual presentation is where we use paragraphs to describe the performance of a company or any individual. So this is textual, means it is sometimes, a lot of paragraphs. We have to read every line to understand. It is not visual. You see, the textual means it is not visual. You have to read. On the other hand, tabular, the moment we show the data in a table, it becomes okay. Table means we quickly at a glance we can see the numbers. Year performance, maybe yearly sales, monthly profit. So once we see the table, the columns and the rows of the table, we can quickly grasp, interpret the meaning of the data. For example, we can quickly understand in which month the particular company has got the highest sale, in which month the company has registered the highest profit. Similarly, if I look at the performance of students in CA Foundation exam, if it is a tabular presentation for the last 5 years, and if the data is presented through geographic as well as time series, then I can quickly understand at a glance by viewing, by looking at the table, by observing the table, that okay, this is who has got the highest marks in CA Foundation exam, from which center, from which city. So it becomes easy for us to view, to read the table, and to come to the conclusion. Now we come to definitely a very important part, and from the exam point of view, very significant. We look at the different parts of a table. So first and foremost, what are the important points of tabulation? Statistical table, when you prepare a table, it must have a title. For example, the revenue of a particular company for the last 2 years, the marks of students from different parts of India in the CA Foundation exam, the pass percentage in the UPSC exams across 5 cities, for example, or 5 regions of the country. So therefore, it should have a title, it should have a serial number, and then please see point number 2, which is there on the right hand side of the slide. The table must have caption, box head, stub, and body. 4 immensely important part of a table which we need to know, identify, memorize, because it comes often as a question in the exam. So caption is the upper body of the table. So it describes the column. You know, the vertical information, whatever information is presented vertically, it is called the column. And the horizontal, the data sets are presented through rows. So the caption will be describing the details of the column and the subcolumn. What is box head? Box head is the entire upper part of the table, which will include the columns, subcolumns, along with the caption. So caption is the smaller part, boxed is the entire upper part of the table. Now we come to the left-hand side of the table. In the left-hand side, we have the description of the rows. So this is called the stub. Stub is the left part of the table, which provides full description about the rows. So rows, columns, and body. And of course, caption. These are the essential elements of a table. And so first we talked about caption, then I explained what is box head, then I referred to what is stub on the left-hand side, and now the main body. What is the body of the table? This is the space where we have the numerical figures, the data expressed in currency, expressed in percentage. It could be expressed in any unit. So the numerical data, the quantification, the quantities which are there. Okay, so I hope you have understood. Please remember once again the four important parts of a table. You have the caption, box head, stub, body. Next, we have point number 3, 4. The table should be well balanced in terms of length and breadth, and there should be row total, column total, subtotal. So if you look at the balance sheet or of the profit and loss statement of any company, visit the website of any company, just download the annual report. From there, if you quickly have a glance at the organization's, the company's financial statements, so the balance sheet, the profit and loss statement, the cash flow statement, or say, for example, the abridged financial statement, what you get is essentially a table, because in case of profit and loss or balance sheet, you have the description of the rows on the left side, you have the columns, you might have sub-columns. So an example of a table could be the financial statement of any organization. Plus, in case of a table, notes describing the source of data should be included. There could be footnotes as well in the bottom part of the table. So therefore, tabular presentation is always preferred because it improves the comparison between the rows and the columns. And without a table, we cannot create a diagrammatic presentation. And even without a table, even statistical analysis cannot be done. Okay, I hope it is clear to you. Now we come to the last part, diagrammatic presentation. There are 3 types of diagrams. We shall learn what is line diagram. Now, in the early part of the 20th century, there was a term which was used called historiogram. Historiogram. Please note, it is not histogram. Histogram is different. This is historiogram. This was the old name, which referred to line diagrams. Then we have bar graphs or bar diagrams, and the third is pie chart. So now we proceed to discuss about line diagram. So in case of line diagram, what we see is we plot the pair of values representing the time series at the point t in the ty plane. So time on one side and maybe the value on the other side, sales over the last 5 years. So we have ty. That means now on the vertical axis, maybe it is, say, for example, we show the value of the sale, the monetary value. And maybe on the other axis, we have the years, year 2024, 25, 26, and so on. Then we have bar diagrams. So now let us look at the first illustration. We have 13.1.1, the first illustration from the study material. So we see here the profits in lakhs of rupees for a company for 2009 till 2015. So the absolute figures are given. The moment we show the figures through this particular line diagram or histogram, this is a line chart, or we can also show it through a vertical bar chart. So now you can see the trend. So from 2009 till 2015, how, for example, the profits of the company has grown. Now you can see the full trail or the trend. This is the plus point or the main advantage of diagrammatic presentation, because today we use a term called dashboards. So the top management of a company, any board member, for example, they may not have the time to go through a lot of paragraphs. Yes, they may glance through a table, but at the end of the day, if they want to get full information and analysis of the company's performance, for example, they would definitely look at the diagrammatic presentation. Even when the Honorable Finance Minister presents the budget of any country, including ours, if you look at the budget document, which is uploaded in the Ministry of Finance website, you would find that a lot of tables are included. It is not just paragraph, it is table. You will find a number of useful statistical diagrams like line diagram, like histogram, like pie chart. For example, to show what is the total collection, the revenue of our country from tax, non-tax, borrowings, the government of India usually displays or depicts this revenue of the country through a pie chart. So from the pie chart, you can see that, okay, this percentage of the revenue comes from income tax, this percentage comes from GST, this percentage is from the non-tax revenue like dividends, and maybe this percentage comes from borrowings. So both for the inflow and the outflow for the Indian economy, for an example, you will find the application of pie charts, you will find the application of different line graphs. So year by year, for the welfare schemes of our country, what is the expenditure which is incurred by the government? You would find something like what you see on the left-hand side of this slide. You will see typically something like a vertical bar diagram. Here we can see vertical bar diagram for the profit. It could also be depicted for showing the expenditure of the government of India for different years. So I would request you to please download the budget document, go through it. While this session is going on, the click of a button, you can download the Union Budget 2026 document. If you go to the website, you will get a link for the abridged, summarized budget. You click on that, should be around 26, 27 pages. Click on the PDF, you will see the statistical interpretation of the budget. Right, so I hope you can see the practical side. That's why I try to link it with economics, with the union budget of our country, so that you understand the practical utility. So next we have another example from the study material. On this slide, you can see example 13.1.2, where we look at the production of wheat and rice. Two ways to show it. On the right-hand side, you can see multiple line chart. So you can see on the x-axis, we have the years 2012, 2013, 2014. On the y-axis, what is shown? The production in metric tons. That means time and production. Both are mapped through a multiple line chart. On the left-hand side of the slide, you can see figure 13.1.4, which shows multiple bar chart. Another way of showing the same data. So what is given in the upper part of this slide is the upper left-hand side. You can see the table. The same data is represented through multiple line chart on the right-hand side of the slide. And on the left-hand lower part, you can see the same information, but it is now displayed through multiple bar chart. And here you can see multiple bar chart. The shaded one is for wheat and the plain is for rice. So you can see the practical application of statistics. Similarly, 13.1.3 shows, I was referring to pie chart. If you look at the inflows, the revenue of a country and the expenditure, how much money goes into defense, how much money goes for the welfare schemes, how much money goes for to take care of the subsidies, the funds are channelized for infrastructure development, how much funds goes into interest payments. Their pie chart is the best way to depict. Here again, you can see a very similar example. The idea here is the source of tax: customs, central excise, income tax, corporate tax, miscellaneous, the revenue. So this is a table. What is given on the left-hand side is a table. And I hope you can see the different parts of the table. For example, the caption, the box head, the stub, the body. But on the right-hand side, you can see a beautiful way of expressing this particular table is through pie chart, which gives us a visual understanding. Visual, we see with the eyes. What we see versus what we read. If you read a paragraph, it gives us some message. But if you see some visual, many people, they try to study through video lectures. So maybe you are able to see, hear and see. So the power of visual is definitely significant. And as a result, we are quickly able to grasp the data, the interpretation, the analysis. So the pie chart shows the distribution of revenue on this slide. Now we proceed to frequency distribution. We look at example 13.1.6. Here, the weight of number of students, 36 students of BBA is displayed. So many students, 36 students, everyone having different weight. So the intention is we have to create a frequency distribution of weights. It is given that the class length should be 5. So first, for any such distribution of data, we have to find the range. Range, as you know, is the maximum minus minimum. For example, say in a particular exam, accounts paper, the highest is 88. And say the lowest is, say, 30. So highest is 88, lowest is 30. So the range is 88 minus 30, that is 58. So here also, the first step is to find out the range. Maximum minus minimum value. Next we know the class length is 5, it is given. So we have 29 kg as the range, and we know that there will be different type of class intervals, different categories. Like, you know, when you see the income tax, income, say up to 5 lakhs, one level, 5 lakhs to 10 lakhs, one level, or say 5 lakhs to 12 lakhs, 12 to 15 lakhs. So you get different categories, different classes, class intervals. So here, how many class intervals need to be created? It is the range divided by the class length. So the range gives you the entire difference between the highest and the lowest observation. And accordingly, if you know the class length, you can quickly create or find out the number of class interval. Clear? So now we can see from the study material, the frequency distribution. Accordingly, you can see the total number of students is 36. On the left-hand side, you can see the weight in kilograms, which is class interval given, tally marks are given, and then the number of students. So this table which you see, table 13.1.5, is an excellent example of a frequency distribution table. The total frequency of 36, the total number of students, 36, they are now distributed across different class intervals. I repeat, dear students, the total frequency of 36, you can see, is now distributed amongst different class intervals. How many class intervals are there? Please see the table. You will find there are 6 class intervals. So total distribution, the total frequency, 36, is distributed across equal class intervals. How many class intervals? 6 class intervals. Okay, I hope you're clear, you're able to follow and understand. Now we look at what is meant by the class limits and the class boundary. So class limits means the minimum value of a particular class. So it is usually denoted by LCL, the lowest class limit, lower class limit, and the other one is the UCL, which is the upper class limit. So lower and upper. Now, there are two types of information which you need to know. First, we have certain items which is mutually exclusive, and another category which is called mutually inclusive, exclusive and inclusive. So, what is exclusive and inclusive? Now, please note there are certain items which will fall only in one category at a time. For example, if I flip a coin, if I toss a coin, it can either be head or tail. That means if a head happens, you cannot have a tail in the same toss. Exclusive. So if one happens, the other will not happen. You can also get certain information or data which could be mutually inclusive. That means here, items can belong to multiple categories. For example, if you draw a card from a pack of well-shuffled cards, say I draw a card at random, say from a pack of cards, this card which I draw at random could be a heart as well as a king. That means it could be both heart and king. This is mutually inclusive. So please understand this concept, mutually exclusive and inclusive, because as we go to the next paragraph on class boundary, you will find that in the ICAI study material, this term is used, mutually inclusive and mutually exclusive. So here it comes, you can see for overlapping classification or mutually exclusive classification. Normally the upper class limits are excluded. So you have 10 to 20, 20 to 30. Here, the class boundary will be equal to class limits. Usually this is done for a continuous variable. That means a variable which can assume any value within a defined range. But there may be mutually inclusive classification, usually for those data which are discrete. That means these data take only specific values within a given interval. So for those type of data, we have to make the distribution continuous. How do we do it? Simply by adding another concept of class boundary. That means 44 to 48 and then 49 to 53. If you see the table in this slide, we are on slide 11. If you see the table 13.1.5, you can see the weights which are given 44 to 48, 49 to 53. You have a gap. 44 to 48, fine, but then 49 to 53, 48 and 49, you have a gap. So now we need to fill up the gap. So how can we do it? Now we will calculate the lower class boundary and the upper class boundary. So this 44 kgs, the lower class limit or the LCL, now gets converted to the lower class boundary and it becomes 43.5. So therefore, we now create, you can see the corresponding upper class boundary becomes 48.5. So the formula is lower class limit minus d by 2, the difference by 2. And upper class boundary equal to the upper class limit plus d by 2. What is d? D is the difference. In this case, you can see 44 to 48. So I'll take 48. Next class interval is 49 to 53. So I'll take the lower class interval, 49. That means difference here is 1. 49 minus 48. So what is this difference or d? What is d? D is nothing but the difference between the upper class limit of a particular class and the lower class limit of the next class. So 44 and 48, one particular class, I am taking 48, the upper class limit. Next class interval is what? 49 to 53. There I am taking the lower class limit, 49. 49 minus 48 gives you 1. So I get D equal to 1 and therefore D by 2 becomes 0.5. Accordingly, we calculate the class boundaries. So what is class boundary? It is a precise continuous value which is introduced to close the gap. Here we had a gap between 48 and 49. To remove the gap and to make the entire data continuous so that no data would fall into the gap or the gray area, we are making the data continuous. So we have 43.5 to 48.5, again 48.5, and then we move to the next class, 53.5, and so on. So this is important for drawing histograms. So I hope it is clear to you. And now we see what is midpoint or the class mark. Midpoint means essentially the middle of the class, midpoint of the class. So it can be the lower class limit plus upper class limit divided by 2, or it could be the LCB, lower class boundary plus upper class boundary by 2. What is the width or the size of the class interval? So it is the difference between the upper class boundary and the lower class boundary. In this example, it was UCB, that is upper class boundary, say it is 48.5, and the lower class boundary is 43.5. So the difference is 5 kgs. This is the width or the size of the class interval. Now we proceed to the next quick, easy concept, and that is we take cumulative frequency. So cumulative frequency, many of you, dear students, you are aware. So we write the frequency for a particular class, say it is 5, and maybe the next class has a frequency, let us call it class 1, first class. You can see on the table 43.5, and maybe the frequency is, say, 0. 48.5, the frequency is 3. So the cumulative frequency becomes 0 plus 3, that is 3. The next class, 53.5, we have 4. Frequency is 4. So the cumulative frequency will become 3 plus 4, that is 7. So you're just going on adding the frequencies of the earlier class intervals plus the frequency of that particular class, and you get the cumulative frequency of the specific class interval. Lastly, we have the frequency distribution, and here we see on the left-hand side, yes, we were already examining and understanding the frequency distribution through table. You can see year and number of cases. So this is an example of a frequency distribution, the time year-wise analysis of the number of cases. So this is frequency distribution. What is the frequency, the relative frequency? The relative frequency, you can see here, we have two concepts, relative frequency and the frequency density. So the frequency density, first we will see the frequency density of a class interval means what is the frequency of the class divided by the class length. So if I say that a class length is 5, say the class is 40 to 45, 40 to 45. Say it's a question of marks in the CA Foundation exam for a particular subject. So maybe the class is 40 to 45. That means 40 marks till 45 marks. Maybe we have, say, for example, we get 20 people who have got this marks. So 20 students are between 40 and 45. So what will be the frequency density? So the frequency density is the ratio of the frequency of the class interval divided by the corresponding class length. Here the class length is 5 and the frequency is 20. So the frequency density is how much? Please calculate. 20 divided by 5, that is 4. Now what is relative frequency? Relative frequency is defined as the ratio of the class frequency to the total frequency. So on the table just above here, you can see 1900 to 1909 and then 1910 to 1919. You can see the number of cases. The total number of cases, if you see year-wise, it is 35, 46, and 51. Together, the sum comes to, the total is 132. What is the relative frequency of the first class, that is 1900 to 1909? What is the relative frequency? Calculation is the frequency of that class divided by total frequency. You get the percentage. So in this case, for 1900 till 1909, the relative frequency is 35 divided by 132 into 100. So you get 27%. So in this way, we calculate the relative frequency. I hope it is clear to you. And now we proceed to the next and the last few parts. We have the charts and diagrams now. So charts and diagrams, the last part, we have bar charts, line diagrams, and pie chart. We have already looked at pie chart and line diagrams. Here we see one or two other examples like a stacked bar chart, which represents components of whole, say here we have male and female gender between certain age group. So this is an example of a stacked bar chart. And on the right hand side of the slide, you can see yet another example. And here we will look at this table. The number of months female and male patients have been enrolled in a hospital or in a nursing home. So what are the number of months on an average where female and male patients were enrolled or admitted by age group? So much of data. First, male, female, gender. Number two, how many patients? Number three, age group. Number four, number of months. So through this table, we can see this stacked bar chart. On the left-hand side, the lower left-hand side, you can see a lot of information presented through a simple diagram. So this is yet another example of diagrammatic presentation of data. One more example is you can see the line graph. This graph shows the number of clinicians working in hospitals or clinics. So maybe for year 1 to 4. So we have taken example of 3 clinics. Clinic 1 in this line graph, the color code is blue. Clinic 2, you can see the color code is reddish. And the third, Clinic 3, the color code is green. You can see on the x-axis year 1, year 2, year 3, and year 4. On the y-axis, you can see the number of clinicians or clinicians who are working. So together, through this display, this is like a dashboard, as we say nowadays. This is a line graph, but it effectively captures essential data in 3 clinics over 4-year span, number of clinicians who are working. So this is the power of visual presentation or diagrammatic presentation. Plus another example of pie chart, percentage of patients enrolled quarter-wise. You know, a year has 4 quarters, so quarter 1, 2, 3, and 4 depicted through different colors. And we see the total number of patients enrolled. From here, we can see percentage of patients enrolled in first quarter is the maximum. Fine. So I hope you're following and understanding each of the concepts. Yes, we have number of new concepts in chapter 13, which we need to understand. Lastly, we look at the histogram, and then we will move to the frequency polygon and the ogive. So here we see histogram or area diagram. Figure 13.1.6 from the ICAI study material. So here all the classes are made continuous. So instead of class limits, we have class boundary. And with the same example which we were analyzing in the last 2 slides, here you can see 43.5, 53.5, 63.5, you can see the class boundaries. Now, histogram, that is, it is like, you can call it just like a rectangular bar chart, but the only difference is all of them are connected and the entire distribution is continuous. So it's not a discrete diagram, it's a diagram showing continuous data. So from here, we can easily see and plot that we see the highest frequency. So number of students or the frequency we see is highest for 66.5. That means weight 66.5 kgs. We have the highest number of students who belong to that same weight. That means they have the same weight, 66.5 kgs. Number of students is the maximum. So therefore, the mode is 66.5. Mode means that particular data set which has the highest frequency, the maximum number of occurrences. So through histogram, we can easily identify the modal class. That means that particular data or that particular class which has the highest frequency. Right? I hope you are able to follow, and it's a very important as well as useful tool which we are discussing, histogram. Okay, this side we have charts and graphs. So frequency distribution, well, these are easily represented through charts and graphs. Histogram, as you can see on the right hand side, is to present graphically. We are showing different types of information. Here we have weights of different class boundaries. 36 students, their weights are displayed. And the adjacent bar indicate that a numerical range is summarized. So 43 to 48.5, 48.5 to 53.5. So each of the endpoints of each of the bar represents the lower class boundary and the upper class boundary. Clear? Now, we look at frequency polygon. So once you have drawn the histogram for each of the rectangles, if you find the midpoint, and if you join those midpoints in the frequency part, you will draw a frequency polygon. So what is frequency polygon? Now in the vertical axis, we are measuring the frequencies. And on the x-axis, the horizontal axis, we are measuring the value of the variable. Like here we have the weights. So frequency polygon means when we join the midpoint of each of the rectangle which you see, but here we identify and connect the midpoints of the frequencies. That means we look at the upper part of the bar, rectangular bar, and we connect the midpoints. And if you join the midpoints through a straight line, we get a frequency polygon. So here we see from the study material the same distribution of data, the weights of 36 students, but now we find out for each of the class interval the midpoint. Midpoint is class interval, the class length divided by 2. So for the first class, the midpoint is 46, then 51, and so on. And once you connect those points, what you are generating is a frequency polygon. This frequency polygon, ultimately, the limiting factor or the limiting feature of the frequency polygon, that means if you have thousands, uncountable number of, say, data set, okay, and say the class intervals are becoming smaller, okay. So it is similar to the concept of limit in the case of calculus. When you studied differential calculus, you must have understood the concept of limit and continuity. So the same limiting concept, if you use, then the frequency polygon which we are drawing now, or the histogram which we were drawing in the last slide, when the number of data sets becomes large, it goes on increasing. The final form of the graph will not be a polygon, it will become a frequency curve. So frequency curve is regarded as the limiting form of frequency polygon. Clear? Now we have the last part, and there we see the ogive or the cumulative frequency graph. So once we find out, we draw a table. On the left-hand side, we have the different class boundaries. For every class, we have the lower class boundary and the upper class boundary. Then we have a set of frequencies, column number 2. The third column is cumulative frequency. And once you draw or plot the cumulative frequency for every class boundary, you will get an ogive. So it is OGIVE, pronounced as ogive. So there are two types of ogive. We can use two types of cumulative frequency, less than and more than. So once we plot the cumulative frequency against each of the classes, less than and more than, once we plot both of them, we get something like an X. So you can see on the slide here, 13.1.8, figure number 13.1.8, you can see there are two lines. You can see the cumulative frequency is now plotted from the left-hand side, upper side to the right-hand side. You can see one line which has gone. It is a heavy continuous line. And the second one you can see starting with 43.5, a dotted line goes up. So if you look at these two lines, these are like X cross. They're crossing each other. One of the line represents the less than frequency, less than cumulative frequency. The other line represents the more than cumulative frequency. Once they intersect, you can see they are intersecting at a particular point. This point is the median. So we have a separate chapter on central tendency where we will discuss about median in details. But please remember, median is the midpoint, the mid value. You might have 50 observations. If you put them in ascending order or descending order, you will get the midpoint. The midpoint, the middlemost value, is referred to as the median. Here we see in this cumulative frequency graph, which is also known as ogive. We have two types of ogives, less than frequency and more than frequency. Once we are connecting them, what we get is an ogive. And in this ogive, in this graph, we have two lines which are intersecting each other at a particular point. This point, when we extend the point on the x-axis, we are getting Q2, which is the median. So please remember, ogives can be drawn in two ways, less than or more than, and ogive gives us the midpoint, the middle value, or the median. That means from the ogive, we can derive the median. So here, for example, the median is 62.5. Finally, we have the frequency curve, a freehand. It's a freehand curve. And it is a limiting form of frequency polygon and histogram. So you can see from the study material, if you see, I was explaining why it is a limiting form. As the number of classes increase, the class width becomes smaller and smaller. Ultimately, the frequency polygon which we see will be replaced by a freehand curve. This is called the frequency curve. It's a smooth curve, smooth and freehand. Now, usually we have four types of curves. We have the bell-shaped curve. That means it is like this. Think of a bell which you see in a temple, a bell. So you can see on the lower part of the slide, you can see the picture of a bell-shaped curve. That means the frequency increases slowly, goes to a maximum, then the frequency comes down. This is a bell-shaped curve. Next, we have a U-shaped curve, which comes up on the slide. U-shaped curve means the frequency is minimum towards the beginning. Sorry, it's maximum towards the beginning. And slowly the frequency, as number of observations are increasing, class boundaries are increasing, the frequency slowly reduces. It reaches the minimum somewhere in the middle, and then again it increases. So it is of the form U. The shape which you derive is U. So we can say the U-shaped curve is the opposite of the bell-shaped curve, right? Now the third is J-shaped curve. So you can see 13.1.11 from the study material on this slide, you can see the J-shaped curve. Finally, we have the mixed curve, which is a combination of one or more of these three curves. We will call it a mixed curve, right? So this is the final part of Unit 1, which we have analyzed and explained what is the concept of frequency curve, why it is called the limiting feature or the limiting form of frequency polygon, and then the four different types of curves. It is a smooth freehand curve. We have the bell-shaped curve, the U-shaped curve, the J-shaped curve, and the mixed curve. And all these curves you will find in real life if you analyze or plot sales data, production data, number of passengers in a flight, number of people arriving at a particular station throughout the day. Okay, so all these different type of data, these are sometimes seasonal. These are cyclic. So we may not get a linear straight line in the graph. We might get a curve. And the curve will be either a bell-shaped or a J-shaped or a U-shaped, or it could be a combination or a mix, which gives us the idea of a mixed curve. Right? So with this, we come to the end of the Unit 1. We proceed to Unit 2, and we have sampling in Unit 2. So in the Unit 1, we have discussed in detail about the objective of statistics. What is statistics, of course? What does it deal with? The applications of statistics. What is data? Primary data, secondary data. We have analyzed and explained what is continuous data, discrete data. Then we proceeded to understand the different ways of data collection. How do we collect the data? How do we present the data? Data presentation. Then we moved on to the tabular form, different types of table. From there, we proceeded to discuss about what is diagrammatic line diagram. Histograms. We talked and discussed and explained about bar diagrams, horizontal and vertical. And finally, we moved on to the understanding of what is cumulative frequency. From there, what is ogive, less than and more than curves intersecting, the point of intersection. Once we find out the perpendicular, once we extend that point over to the x-axis, what we get is the median. And thereafter, we discussed and explained to help us in understanding what is frequency curve and how frequency curve becomes the limiting form of the histogram and the frequency polygon, plus the four types of frequency curves, which is a smooth freehand curve. Now we move to Unit 2 of Chapter 13, which is sampling, a very practical part, because especially when you think of auditing, one of the core role of a chartered accountant is the work as an auditor, the service we provide to the nation, to corporates as an auditor. In audit, sometimes we are unable to check 100% of the transactions because the transaction will be huge, volume is huge. So we usually follow the sampling. We select a particular part of the entire size of the transactions. So maybe out of 10,000 transactions, we will check, say, a sample of 30%, maybe 3,000. So how to select the sample, how to draw the sample. This is what we learn in sampling. So the objective of this Unit 2 is for the students, they will understand what is sampling, what is meant by population and sample, what is meant by parameter and statistic, and applications of sampling, how to draw the sample, different types of sampling error. Very practical, relevant, specifically in our role as a chartered accountant. And therefore, sampling, you will find, if you just check online, you will find that the Institute of Chartered Accountants of India, sampling, how important it is. Sometimes we feel that, oh, this is mathematics. I am going to become a chartered accountant. Why am I studying mathematics? Why statistics? No, this wrong. Thinking is wrong. As I was mentioning, and as explained in the study material, please remember, today the role of a chartered accountant, a finance professional, is entirely based on mathematics and statistics and logical reasoning. Without a sharp and deep knowledge of statistics, I cannot become a good auditor. I cannot become a data scientist. Many chartered accountants are working in artificial intelligence. They are experts in coding. They are predicting the data. What will be the result? What will be the outcome? But that skill, that expertise is absolutely built upon a solid understanding of sampling, of statistics. So to be an auditor, we have to understand sampling. And if you look at the standards on auditing, you know about accounting standards. You must have read about accounting standards. You know, under the Companies Act 2013, which is part of your law paper, you know that accounting standards are to be followed in a compulsory manner. Every entity has to follow accounting standards. Similarly, auditors need to follow the auditing standards under Companies Act, Section 143, subsection 9 and 10 of Companies Act 2013. Do you know that out of so many auditing standards, we have one standard specifically on sampling? So if you check, you will find two standards. One is SA 530, standard on auditing 530 on sampling, and one more standard, SA 520, standard on auditing 520 on analytical procedure. From these two, if you just go through the summary of these two standards online, if you just get an AI summary or a Google summary, you will 100% appreciate what we are discussing. You will understand. And you will get the interest in statistics because you will see analytical procedures clearly says the standard on auditing, SA 520, issued by the ICAI, which is compulsory, which is notified under the Companies Act. The standard deals with the use of ratio, trends, and statistical tools. And the standard SA 530 on sampling extensively covers all the terms, all the principles, all the techniques, every tool which we are going to discuss here. So sampling is not just statistics. I should understand that statistics is an integral part of my CA curriculum. It is no longer, it is not just a paper of foundation, but the principle, the knowledge I'm gaining will show me the right approach even in technical papers like audit. So please check SA 530 so that you understand the practical importance of sampling, especially, of course, in our role as a chartered accountant in audit. So what is a sample? A sample is a smaller but a representative collection of units from the entire population. So you have a class of 50 students. I want to find out the average marks of the class in accounts paper or in QA, quantitative aptitude. I may not have the time, I don't have time to reach and go through all 50 mark sheets. So what I do, I randomly select out of 50, I randomly say they are sitting in a classroom. I randomly select, I find, okay, there are 10 people, 10 people sitting in, say, 5 rows. There are 5 row number 1, 2, 3, 4, 5, 10 people. So I say that, okay, from row number 1, student number, say I draw out of 50 students, I want to create a sample, say, of 10 people. 10 out of 50, that is 20%, 1/5. So what I do is I don't have time to go through all 50 students' mark sheet. Everyone is having the mark sheet. I want to quickly create a sample. So what I do, from row number 1, I randomly look at the 10 people and say, okay, student number 7 and 9, please come forward. Submit your mark sheet. Row number 1, I have done. Then I go to row number 2. I think my favorite number is 2. So I use the number 2 and the multiple of 2. So I say that for row number 2, the second student and then the fourth student, 2 and 4, multiple, please come forward. So from row number 1, I have got 2 mark sheets, student number 7 and 9. From second row, I am randomly selecting two students, student number 2 and the student number 4, who are sitting in the second row. I go to the third row now. I will select two students from here, from the third row. So I think, okay, third row, let me select the two people sitting in the extreme. So I select the two students who are on the left-hand corner and the right-hand corner. That means I am selecting from the third row, I am selecting a sample, and I'm calling student number 1 and the 10th student. You understand? You follow? 10th student. So 1 and 10. So I have got 3 rows now, and I've got 6 people from 3 rows. I now proceed to the 4th row, and now I use another sampling table, and I select 6 and 8. 2 students, 6 and 8, from row number 4. And the last row, row number 5, there are 10 students. I suddenly think that, okay, 10 students, let me select the 2 students who are sitting in the middle point. So you have 10 students. So you will definitely, 10 is an even number. So you will find there are 2 students who are occupying the middle places. So I select those 2 students. So typically, if you see, we are getting 2 people. So person number 5 and 6. So I'm saying that, okay, student number 5 and 6, please come forward. Because student number 5 and 6 essentially occupying the middle part. There are 10 students. So now I have created, out of these 50 students are there in the class. I want to know the average marks of the entire 50. I do not have the time to jot down all 50 marks, find out the average. I am in a hurry. At the same time, I want reliable result. So what I have done, I have quickly created a sample dividing the 50 students into 5 rows, each of 10 students. I have randomly selected 2 students. From row number 1, I have taken 7 and 9. From row number 2, I have taken the marks of student number 2 and 4. From the third row, row 3, I have selected the 2 extremes, student number 1 and student number 10. From the fourth row, I have selected 2 people randomly again, student number 6 and 8. And from the fifth and the last row, I have requested the 2 students sitting in the middle, student number 5 and 6. Well, I have got a sample now. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students, 10 mark sheets. So instead of 50, this 10 mark sheet, I will now find out the individual 10 marks and calculate the average. So you can see from this example, what will I say? These 50 students. So this example I am creating on the spot. It's not there in the presentation. So just please listen carefully. So these 50 students you see, we will call it the population, entire size of the data set. This 10 students I have created, 10 students. From each of the row I have taken 2, 5 rows. So 2 students into 5. This 10 students I have created is the sample. So I hope you can see that sample is a part of the population. So what is the purpose of sampling? To gather data about the population, because I wanted to find out the average score of the entire 50 students. But I will try to do that by finding out the average marks of these 10 students. Well, you will immediately say that how is it possible? 50 students, their average, and the average marks of these 10 students, it may not be the same. There will be some difference. There will be some gap. You will see this is called the standard error. We will look at it later. So the average of the sample and the average of the population will never be equal. Only in the most efficient sampling technique, you will find that the 2 averages will almost become equal. But the intention in statistics is to achieve a result where the sample mean, the sample average, like I talked about the average marks of the 10 students and the average marks of the 50 students, they must be as close as possible, as close as possible. So the population sample, they should be the average, should be as close as possible. Right? I hope you are listening and understanding. This is sampling. So it is highly practical and very interesting. Also, it's all these, both these two chapters, very scoring in the exam. So intention of sampling is to reduce the cost. Yes, time. I don't have the time to check 50 marks. I can quickly check 10 students' marks out of 50. Similarly, in audit, sometimes we don't have the time to check 1 million transactions. Say you are doing the audit of a bank. You are conducting the audit of a large listed company. There are millions of transactions. You know what is a transaction, any financial transaction. We won't have the time. We won't have the budget. We won't have the manpower to check 100%. Of course, now with AI data analytics, it is possible technically, but still to a large extent in the real life, in the practical world, we still follow sampling. So sampling saves time. Proper sampling saves the cost and the effort, right? So these are the importance of sampling. So now we look at the techniques. So I hope you have understood what is population. Population will have its own average, like the average marks of the entire 50 students of the class versus the sample which I had drawn, 10 students. I told you and I explained step by step how I selected 2 students from every row. There were 5 rows, each with 10 students. I selected systematically 5 rows, 2 students each. So I created a sample of 10. Now there, 10 people are there, 10 students, their marks, the average of the marks of the 10 students will give me the sample average or the sample mean, as we call it, MEAN, mean. And the 50 students, the average marks of these 50 students will give me the population mean. So you have, for the 50 students, 50 students, 50 students, you have population mean. For the 10 students, you have the sample mean. These population mean and sample mean will never be equal. In most of the cases, it will not be equal, but the intention is, the objective of sampling is to do it to create the sample in such an objective manner, scientific manner, that the sample mean will be quite close, very close to the population mean. There will be a difference, but the difference also can be calculated. So therefore, there are 2 methods of drawing sample. We have probability sampling and non-probability sampling. We are taking now the probability sampling, which is the first part. So let's see, population universe I explained. Sample is a part of the universe. You can see the study material definition is given. A population could be finite or infinite. Yes, population could be infinite. Right, so the number of units which are there in the population is population size. In the example I was explaining with 50 students in the class, this is population. 1 million transactions of a company in a financial year, total population. But out of 1 million, 10 lakhs, maybe I will check only 40 lakhs. 4 lakhs. So it is a 40% sample I'm drawing. 1 million, 10 lakh transactions. From there, a 40% sample, that means I will check 4 lakh transactions. So I must select the 4 lakh transaction from that 10 lakh transaction. I cannot select it blindly. I must select the sample properly, statistically, in a random manner, so that the sample's performance will be close to the performance of the entire population. So I hope you're able to understand and follow. So sample is a part of the population, as I said, and sampling has a tremendous importance in, as I said, in auditing, in every professional field. So you can see in this diagram, we have an entire green color diagram. You can see a elliptical geometric figure, which is the population, and you can see a smaller figure where it is written sample. So sample is a part of the population. So population of the universe means collection of everything, like 1 million transaction of a company, 50 students of a class, population. Sample is a part or the portion of the population which we are drawing or which we are creating for the purpose of analysis. Like I was creating a sample of 10 students out of the population of 50. Clear? Okay, so now we come to parameter. So the population mean, I was talking about there were 50 students, population is 50, and the sample size is 10. Okay, so those of you who are following, students who are following this session, you may remember a couple of minutes back, I was explaining how I created the sample of 10 students. I selected 2 students from every row randomly to create 10 students. That was a sample I created. So the average marks of the 10 students is called, the 10 students marks will be called, the average is sample mean. And the average marks of the 50 students is the population mean. So now we will see that the sample mean or the deviation, the standard deviation of the sample is known as what we call the statistic. Please see, it is called statistic, not statistics, not plural. Statistics is the entire subject. You have S at the end, statistics. I repeat, statistics, S at the end. But this is singular, statistic, C at the end. So you are learning 2 terms today, statistic and statistics. Both have totally different meaning. Okay, so statistic is what? A statistic is a summary of a characteristic of the sample. So the 10 students, those 10 students, if I find out their average marks, say the average marks of the 10 students comes to 55. And the entire population, maybe the average marks, if I work out all the 50 scores, and if I find out the average, maybe it comes to say 51. So I have the population mean or the population average, which is 51, and the average of the sample, which is 55. So there is a small difference of 4. So this 55, that means the sample average is called the statistic, whereas the population average of 51 is called the parameter. So now we see another diagram here. You can see the full population, the number is capital N, and the sample or the population mean is denoted by mu. This is a letter from originally the Greek alphabet. It is a mu. It's called mu. Like you have alpha, beta, gamma, delta. So this is mu. And the standard deviation which you see is known as sigma. Yes, what is standard deviation? We will see later. We have another chapter, measures of dispersion. Standard deviation means the individual marks, how much are they varying from each other? Okay, so standard deviation. So if I just give a simple example for the time being, because you must know what is standard deviation in basic terms. So say, think of 2 companies, company A and company B. Both the companies have the same share price. You can invest in any one company, any one out of the 2. For the last 3 years, पिछले 3 साल में company A का dividend, company A has paid dividend, the percentage is as follows. So year 1, year 2, year 3, I'm just developing this example right now here. It's not there in the PPT. Say company A has issued dividend. Year 1, it was 15%. Year 2, it was say 26%. Year 3, it was nil, no dividend. Company B, on the other hand, in year 1, they had paid 8% dividend. In year 2, they had offered around 12%, and in year 3, they declared a dividend of 9%. So if you see, company A has declare dividends of 15% in first year, 26% in second year, and 0% in third year. No dividend in the third year. So I hope you can see wide fluctuation. 15%, then 26, and third year 0. My God, it's a huge up and down. On the other hand, company B's dividends are 8%, then a little high, 12%, and then again a little fall, 9%. So the gaps or the differences are much less. That means company B offers more stable and more predictable dividends. So the standard deviation, the variability of company A is much higher than the variability of company B. And later on in finance, risk management, you will learn that risk is measured by variance, by standard deviation. So company A might have a more risky business venture. So the risk could be more. Investment risk could be more in case of company A. So this is just an indicator. So please see, this is the concept of standard deviation. So I hope you have understood it. Now we look at, for the population, you have three parameters. The number is total size. Please think of the example we have taken. 50 students in the class, that is population. It is denoted by capital N. And then you have mu, which is the average of the 50 students. And as per our example, I took the mean, the population mean assumed at 51. And there is a standard deviation for the entire population. We will write it as sigma. And then, as we saw, that it's not possible to measure the entire population. It takes a lot of time. It is costly. Plus, it will involve manpower, efforts. So we always try to take a shortcut by drawing a sample, as you can see on the slide. So for the sample, like the students, out of 50 students, I designed a sample of 10, and the sample average or the sample mean, I came to 55, right? So here on the right-hand side, you can see sample size is denoted by N. So in our example, the population size is 50, capital N is 50, whereas the sample is 10 students, so small n is 10. We have taken 10 students as sample. The population mean, as assumed in my example, is 51. So mu is 51, and x, that is the sample mean, comes to 55. I hope you are able to see the difference between population and sample and the different terms which we use. Finally, we see the standard deviation of the population. If you look at the population, the standard deviation of the population is denoted by sigma, whereas the standard deviation of the sample is denoted by small s. Okay, so you can see the difference. Please see the slide once again. Kindly see the slide once again, and please think of the example I have taken. Please see the example. Please think of the example I have taken. That is the example of the students in the class, 50 students, population, and 10 students, sample. Okay, so now we see the next slide. And as I was mentioning before that, you can see we are on slide number 20, and you can easily see that the mu, the population mean, may not be equal to the sample mean. Probably not. Like in our case, the population mean is 51, but the sample mean is 55. So it will never be same. In most of the cases, it will not be same. But the intention in statistics, the objective in auditing, the objective in the world of finance, the objective in when we do a survey, a complete survey versus a selective survey, the intention is that these two numbers, mu and x, population mean and sample mean, should be as close as possible. Statistics will never be 100% exact, but it should give us overall the right direction, the right trend, the correct approach, the correct conclusion. So you can see the intention of sampling here. I hope you are able to understand through this problem and through this example which I have cited, what is the relation between population and sample. So now we see the study material once again. So we are going through each and every paragraph of the ICAI study material. Now we see the three important rules of sample, very critical for the exam. Dear students, we have certain rules, basically 4 rules, but you will find a lot of similarity between the rules. First is law of statistical regularity. What does it say? It says that if a sample of fairly large size is drawn from the population, then the sample would possess the characteristics of the population. So in our example of the students, I took 50 students of the class. I mean, there were 50 students in the class. I created a sample of 10 students. I got some answer. Sample average came to 55. But if I increase the size of the sample, for example, in an audit, in a company, there are, say, 80,000 transactions in a year. Say, for example, I create a sample of 10,000, or maybe say, let us take 20,000 transactions. Out of 80,000, I am checking 20,000. That means 1/4. That means 25% of transactions are included in the sample. 25% I am checking, 25% transaction I am checking. I am achieving a certain level of accuracy. I am getting a certain level of assurance that, okay, I have checked 25%. Now, the other auditor, another, say in second year, I am able to check 40,000 transactions out of 80,000. That means now my sample size is 40,000 out of 80,000, which means I have achieved a sample size of 50%. Whereas in the last year, the sample size was just how much? 20 out of 80. That is, it was only 25%, but now the sample size has increased from 25 to 50%, which means the accuracy level must also increase. So the rule is, with the increase in the size of the sample, what will happen is the accuracy level will increase. That means the sample average and the population average should become closer. This is the concept of what we see, the law of statistical regularity. And if you see the second rule or the principle of inertia. So what does it say? The principle of inertia says that as the sample size increases, what will happen? Accuracy, I mentioned about accuracy. Accuracy, reliability will increase. So please see point B of the slide, very important principles. I repeat once again, dear students, please study all the theory parts. Please never think that, okay, only numerical is practical, others are all useless. Never, never. Please don't. All theory is important. Without that, won't know the principles. Theory is always the foundation. Never think that, okay, I'll do few practicals, I get to know everything about the chapter. It's a wrong idea. So please make sure you go through the theoretical principles. These are the concepts. This is you will remember. Formula I might forget, but the principle I will never forget. Okay, so please remember these 4 principles, very important for the exam. So we have the principles of statistical regularity, then we have the inertia principle. That means larger the sample size, more will be the accuracy, more will definitely the accuracy level will increase. And what we will get is that we will also increase our precision. Principles of optimization means that we need to create a balance, efficiency at a minimum cost or maximum efficiency at a given level of cost. Last, we have principle of validity, which means that if you use the proper sampling process or the method in designing the sample, then only we will get the correct result, that is valid result. So I created a sample of 10 students from a population of 50 students in the class. I selected 10 students to create a sample. I designed a sample of 10. But the process by which I design the sample is equally important. For example, out of 50, if I randomly select those students whom I know, maybe I know some of them, or whom I have met before, so I know their face. Based on face, maybe out of those 50 students, I know 15, 15, 50 mein 15. I select out of the 15, I select 10. I know you, come. Hey, I know you, please come. If I do it, it is no longer statistical sampling. It becomes purposive sampling. It becomes biased. It becomes judgmental sampling. So it is non-statistical sampling. It becomes subjective. This sampling may not. So if I select those 10 students based only on their face, just because I know their face, well, this may not be the right approach. So this is the principle of validity, which says the design, the method, the sampling design will be valid only when we use a proper systematic probability-based approach. Okay, so these are the 4 principles. So now we look at the difference between sample survey and complete enumeration. So as this is very simple, so we can see that sample survey is usually used. Why? Because of speed. You can complete the analysis with higher speed. Cost is reduced, like even in the case of typically when we talk about any type of sample. For a company, for example, when say the company is producing certain items, can they check all the output? Say they want to identify whether there is any fault. Just imagine, simple example, crash test of car. गाड़ी जो बनता है उसका क्रैश टेस्ट होता है. आपको पता है एन कैप रेटिंग होता है. इंडिया में भी दूसरा रेटिंग मिलता है. हर ब्रांड की गाड़ी को मिलता है. Provided the auto company goes for the crash test. So crash test, when it happens for any company, every company internally after the cars are produced, can they select all the cars? They have produced 10,000 cars. Will they send all the 10,000 cars for crash test? No. They will select a sample. So maybe out of 10,000, they will select 10 cars. And they will now test these 10 cars under actual conditions, and typically under like what happens in an accident. They will do a simulation. They will see out of the 10 cars, how many cars are damaged. And maybe some dummy passengers. You must have seen videos of how crash test is done. So this is also done through sampling. Best example of sampling is now blood test. Any medical test, will the doctor pull out the entire blood? No, the clinician, no. So a sample is taken. We always say blood sample is collected, right? So this is accuracy. It increases accuracy, reliability, plus sometimes we don't have so much of time to check the entire population. So these are the reasons why we have sample, but we should be careful not to be biased. So if you see a biased estimate, so you can see the true value here in the midpoint. But if I create a biased sample, you can see the dots on the left-hand side. That means the entire sample, all the observations in the sample are on the left side of the true value, which should not be the case. It should be distributed both on the left and the right-hand side. But here you can see this is an example of a biased estimation. So I hope you are able to understand. Please read the study material carefully as we later on to identify the areas where you need to revise once again. Please read deeply all the study material, watch all the videos. You can always pause the video later and understand once again the important concepts. So now we look at errors in sample survey. Sample design करने में कुछ गलतियां हो सकता है. There will be some errors. So generally these are divided into 4 categories. So you might have coverage error. Maybe the right person is not selected in the sample. The right object is not selected. There may be non-response errors. there could be sampling errors, plus there could be measurement errors. So there could be faulty demarcation of units, wrong choice. जैसे we always use statistic and parameter. Statistic means average or standard deviation of the sample. Sample से जुड़े हुए जो important parameter or I would say important measurement, उसको हम लोग क्या कहते हैं? We use the term statistic. Population से जुड़े हुए जो important इंडिकेटर है, जैसे पॉपुलेशन एवरेज, पॉपुलेशन का मीडियन, पॉपुलेशन का स्टैंडर्ड डेविएशन, इसे हम लोग कहते हैं पैरामीटर. सो इफ द सिलेक्शन ऑफ द स्टैटिस्टिक इज नॉट करेक्ट, इट विल गिव रॉन्ग रिजल्ट्स. सो दीज आर सम ऑफ द एरर्स व्हिच यू नीड टू नो इन केस ऑफ sample. Plus we might have some non-sampling errors as well. Next up, if we have parameter and statistic. So as I was explaining through the example, parameter means it is a number that describes a particular feature of the population. जैसे आपको कैसे याद रखोगे कि कौन सा पॉपुलेशन के साथ जुड़ा हुआ है, कौन सा स्टैटिस्टिक? पॉपुलेशन फर्स्ट लेटर क्या है? पॉपुलेशन शब्द का द फर्स्ट लेटर ऑफ द वर्ड पॉपुलेशन स्टार्ट्स विद पी. द फर्स्ट लेटर ऑफ द वर्ड पैरामीटर ऑल्सो स्टार्ट्स विद पी. सो पैरामीटर बोलने से आपको याद रखना है कि दिस इज लिंक्ड विद पॉपुलेशन. ऑन द अदर हैंड, सैंपल, द फर्स्ट लेटर ऑफ द वर्ड सैंपल इज एस. द फर्स्ट लेटर ऑफ द वर्ड स्टैटिस्टिक इज ऑल्सो एस. So sample bolne se you quickly remember that okay, the word statistic and the word sample both have the first letter, they have the same first letter S. So you will think that okay, this means the word statistic is linked with sample. So in this way, statistic is linked with sample, parameter is linked with population. Okay, so you can see the definition given in the study material which I have reproduced here, and you can see that mu, like I was mentioning, mu is what? Mu is the measurement of the population average. Yani population ka mean average is denoted by mu. In our example of the class, you saw that class में 50 बच्चे थे, मैंने एक sample बनाया 10 बच्चों का. So population mean, I have taken an example, an assumption that the population mean is 51. Yani mu is 51. Whereas if you look at the sample mein there were 10 students and the sample average, according to my assumption, was 55. So we can say the average of the sample, that means X bar, is 55. So the intention is, now we will see the last part of this chapter, this unit 2. There are two remaining parts. We will see what is sampling distribution, sampling error क्या है, और आखिर में we will see the different methods which we use in sampling. So here we see the definition of parameter, statistic. I hope you are clear about the difference between what is parameter and what is statistic. Parameter को indicate करने के लिए we use two measures. Population mean is shown by mu. Population SD, yani standard deviation, is denoted by sigma. Whereas on the right hand side, I have reproduced the important relevant paragraph from the ICAI study material, where you can see that the sample mean is denoted by X bar and the sample standard deviation is denoted by S. So this slide is equally important. You can see I have given a table at the end. On the right hand side, lower part of the slide, you can see mean is a parameter for the population, of course, it is denoted by mu. The sample mean is denoted by X bar. Standard deviation for the population is a parameter, it is denoted by sigma, and the standard deviation for the sample is denoted by S. And number of elements, वो सिंपल सा एग्जांपल याद रखिए कि क्लास में 50 बच्चे हैं, फुल पॉपुलेशन, मैंने एक सैंपल ड्रॉ किया 10 बच्चों का, सैंपल साइज इज 10, population size is 50. That means number of elements, capital N here is 50, and the small n, that means the number of students in the sample is 10. That means small n is equal to 10. Right? We proceed now to sample distribution and वहां से हम लोग sampling error अभी देखेंगे. So, in short, sampling distribution means कोई भी population से. Now, from that same example, 50 students, I created a sample of 10 students. Row number 1, I took student number 7 and 9. Row number 2, I took student 2 and 4. Row number 3, I identified 2 students sitting on first position and 10th position. Row number 4, I requested students who were in the 6th and 8th student to come forward. And the last row, I selected student number 5 and 6. This is how I created my own sample of 10 students. But from the same 50 students, if you select your own sample, the students would be different. You will also create a sample of 10 students, but your selection of students would be different. In this way, we can select number of students, number of samples from the same 50. हर sample में जो students होंगे वो differ करेंगे, अलग अलग sample बना सकते. We can create different types of sample, each of size 10 students from the original population. यानी हर sample जो draw किया जाएगा, जो design किया जाएगा, आपस में सारे sample का average अलग अलग होगा. That means a sample will have different statistic. The average of all the samples, sample 1 मैंने create किया, say sample 2 you are creating, another person is creating sample 3. So these 3 samples, sample 1 the average was 55, sample 2 average could be 49, sample 3 average could be 60. That means the averages of individual samples will vary. Sampling distribution means, and the sampling fluctuation indicates, that every sample which we draw from the population will have different members, and therefore the statistic will vary. And therefore we come to the next point, that as we can see on the left hand side from the study material, the sample, in our example, we took the sample average was 55 and the population average was how much? 51. 55, 55 or either population average 51, 51. There's a difference. So we will call it error, galti, error, a gap. Mathematically, it is possible to identify kitna gap hai. Very important formula which we use even in audit when we create samples. What is the formula? Please see on the left hand side. This is again a formula which you need to remember. There could be questions, numerical questions based on this concept. We have standard error, SE equal to sigma by root n, where sigma is the standard deviation of the entire population. And small n, जो आप देख सकते हो, root n, small n is what? It is the sample size. Study material में क्या लिखा है? SRSWR. What is SRSWR? SRSWR means simple random sampling with replacement. That means what I am doing is, statistical sampling का मतलब क्या है? That means random sampling means every element in the population has equal chance or probability of getting selected. यानी वो जो 50 स्टूडेंट्स बैठे थे वहां पे कोई भी एक स्टूडेंट का सैंपल में शामिल होने का प्रोबेबिलिटी बाकी स्टूडेंट से इक्वल है. दैट इज कॉल्ड रैंडम सैंपलिंग, प्रोबेबिलिटी बेस्ड सैंपलिंग. सो स्टैंडर्ड एरर का दो रिलेशन है जो आपको याद रखना है. स्टैंडर्ड एरर इज सिग्मा बाय रूट एन, स्मॉल एन. This is for sampling with replacement. That means I am drawing the sample. मैंने जो sample draw किया, मान लीजिए एक बॉक्स में there are 10 balls, 10 कलर का बॉल है. I am drawing a sample of 3. थोड़ा combination, permutation combination को जो problem you have solved, that out of 10 balls in a box, each of different color, how many samples can you draw, or how many times can you draw a sample of 4? In how many ways can you create a group of 4 people out of 10 people who are sitting? So you are drawing a sample. So replacement with replacement or without replacement, what is the difference? With replacement means I am drawing the sample. Maybe I am selecting out of 10 people, I am selecting Mr. X. I am asking him to come out. He is part of the sample. Then I am saying, Mr. X, you go back to the group, go and sit. I will create another sample. That means I am replacing Mr. X back to the sample. Back to the population. वो 50 स्टूडेंट बैठे थे, उसमें एक बंदा है मिस्टर एक्स. So I'm creating a sample. Mr. X is selected. He comes out. He is part of a sample. Then I replace him back to the class. I ask him to go back and sit in the classroom. That means I'm replacing the unit back in the population. That means next time when I draw the sample, again Mr. X will have the same probability of getting selected. This is called SRSWR, simple random sampling with replacement. So इसका opposite क्या होगा, dear students? It will be SRSWOR, simple random sampling without replacement. That means इस बार out of 50 students, I am drawing a sample of 10 students. Let us assume out of 10 students, मैंने number बता दिया, row number 1 में कौन कौन बैठा है. Say out of 10 students which I have drawn, there are 3 students. First person's name is, say, Ranjit. The second person's name is, say, Abhijit. And the third person's name is, say, Sneha. Ranjit, Abhijit, and Sneha. Out of 10 students, in my first sample, Ranjit, Abhijit, and Sneha, these 3 students are there. If it is SRSWR, that means what I will do, I have created a sample, then I will tell these 3 students, along with the other 7, सारे जो 10 students, I will tell them, go and sit again in the class. I will draw another sample. This is SRSWR with replacement. If I do SRSWOR without replacement, then what will I say? So I have drawn a sample of 10 students out of 50. ये 10 students को मैं कहूंगा कि sir, you already are part of sample 1, you go and sit separately. Now I am left with 40 students. Out of 40, I will create a sample of 10. That means I am not replacing these 10 students back to the class. So I mentioned just the name of 3 students, Ranjit, Abhijit, and Sneha. And there are 7 along with them. So these 7 and plus 3, 10 people, I am telling them, for example, out of 10 students, maybe I know Ranjit, Abhijit, and Sneha by name. So I'm telling them that Ranjit, Abhijit, Sneha, and along with you, ये जो 7 students है, आप लोग अलग बैठो, don't go back to the same classroom. That means I am not replacing these 10 people back to the class. So next time when I draw the sample, I will have 40 students because ये 10 बच्चे अलग बैठेंगे. This is SRSWOR, simple random sampling without replacement. So इसका अलग formula है. Now you can see the definition here. Sample with replacement means after any element randomly selected, replace it and randomly select another element. जैसे I selected 10 students, then I told them to go back and sit again in the class. Sampling without replacement, SRSWOR, make sure that on each stage, each element remaining in the population has the same probability of being selected. That means I have already removed the first sample, 10 people. We have 40 students. Each student who are still part of the population, they have equal probability of getting selected when I draw the second sample. This is SRSWOR. Uska alag formula, standard error, please see, for SRSWOR is sigma by root n multiplied by another factor n minus n, capital N minus small n, divided by capital N minus 1. Please remember these 2 formula. So sampling is, yes, very mathematically very engaging, right? So this is sampling error we have done. Last part of our syllabus, and then we will see the questions. We will solve some of the important questions. Yes, it's a long session because we have two most important chapters or units of statistics which we are covering. First, we look at the units, the types of sampling. So we have in our curriculum for the exam, we need to understand probability sampling as well as non-probability sampling. So as I said, probability sampling means those sampling methods where every member of the population has equal probability or equal chance of being selected as part of the sample. So this is probability sampling. Non-probability means any method which uses judgment. Just as I was saying that out of 50 students, maybe there are 10 students whom I know by face, I know by their first name. So out of 50, if I just call those 10 people based on the fact that I know them, or maybe some of them are my neighbors, well, this is biased. This is not random. This is not statistical. It is non-statistical, non-probability sampling. Finally, mixed sampling. Mixed sampling means a method where part of it is based on probability sampling, part of it is based on non-probability. Finally, we look at each of these methods in a little detail. So what is SRS? Simple random sampling means randomly select a sample from the population, keeping in view that every item of the population must have the equal probability of being selected. That means totally unbiased. कोई भी subjectivity का यहाँ पे chance नहीं है. Fully we are using objective method. Once again, dear students, you are all future chartered accountants. I will once again remind you, if you have not yet noted down that particular auditing standard number, please once again check it, SA 530. ICAI standard on audit sampling. Just search audit sampling. You will get detailed standard, and you will find, if you see the standard, you will find each of this concept, each of these terms are there, which proves that statistics is so practical, it is so useful, and sampling is one of the most interesting and scoring chapter units of our curriculum. So we have discussed simple random sampling. Next, what is systematic sampling? What I am doing here, I am selecting every kth element. Say out of 10,000 people, I am selecting first a random number, say a starting point. Say I select a random number. Say today's date is what? Today's date is 14th. So 14th, 1407-2026. Random date. It's a random date. So I take a random, this is called random number, today's date. 1407-2026. Let us add all the digits. 14, 1 plus 4. 5, you get 5. 07, July 07. So now 7. So 5 plus 7 equal to 12. 2026, let us add all the digits. 2 plus 2 plus 6 plus 0. Yani 6, 7, 8, 9, 10. I'm getting 10. So kul mila ke today's date 1407-2026. If you add up all the digits, you are getting 1 plus 4, 5. 5 plus 7 is 12. 12 and 2 is 14. 14 and 2 is 16. 16 and 6, I am getting 22. In this way, let us take the starting point as 22. So please see the definition of systematic sampling. After a randomly selected starting point, ये starting point कैसे randomly select किया जा सकता है, उसी का एक उदाहरण, an example I have just cited, taking today's date as an indicator. So I'm getting a random number 22. From 22, I will select, say, every 10th person, या 10th object. That means now I will select 22, उसके बाद 32, उसके बाद 42. इस तरह से I will select people or object from the population. This is called systematic sampling. Then you have stratified sampling, where the entire population divided into demographic strata या फिर segment. So in India, we have so many states, so many UTs. So we want to find out the average income of people of India, per capita income. Not possible to find out the entire population and find out each and every person's income. So we create a random sample, but our sample should be broad-based. It cannot be regional. For example, if I select 1,000 people living in a particular state, say Karnataka or Maharashtra, it will not give me the right answer. It will become biased. I cannot blindly select 1,000 people from Assam or from the Union Territory of, say, from Delhi. I cannot do that. Bias, regional bias, geographic concentration. I must spread that 1,000 people I will select as a sample by first dividing our country into separate strata. Northern region, southern region, western, eastern, central. Then this is strata number 1. Uske baad second strata, the states which are there. Uske baad we will go down to the districts. This is how we are trying to create a proper sample. Stratified. This is stratified sampling. Population is divided into demographic, segment, phase, groups, or strata. Then you have haphazard sampling, which is non-statistical, of course, like street corner interview. You must have seen media reporters. Think what you see on media. They are, say, for example, accident site. There is an accident site. Yeah, if there is some political rally going on or there is some other incident. So they will stand with their entire camera person, everyone. They will get hold of the person who is walking by. Sir, please, can you come? Please give me your feedback about what this incident. Sir, give me the opinion on the budget. This is what? Man in the street survey. Also known as street corner interview. Say a YouTuber, he or she is doing a review of a well-known restaurant, but the restaurant is new. काफी ट्रेंडी है लेकिन नया है. वो एक ओपिनियन सर्वे कर रहा है. You know, exit poll, very important in any country's politics. Just before the actual results of the poll is declared, you get the exit poll. Exit poll में होता क्या है? Certain people who are, say, physically or geographically close by, like here you can see mall intercept interview. वो जो मैं रेस्टोरेंट बोल रहा था, new restaurant has come up. So the YouTuber, what he does or what she does is randomly, people are walking inside the restaurant, coming out. So people who are coming out, he or she will just ask for the opinion, the feedback or the review of people who are walking in or walking out. Similarly, mall. So many people in the weekends, they go to mall, hypermarket. So these type of interviews which is conducted, these are examples of haphazard sampling, also known as non-statistical sampling. So these may be biased as well. So I've given one more example, sampling to find out the job satisfaction of employees. Maybe the population is 10,000 people in a company. We want to find out the average or the overall job satisfaction. People in the company, 10,000 employees, are they highly motivated? Are they really happy? Are they average so-so? Or are they are very unhappy? They are dejected, they are demotivated. So poor satisfaction, average, and highly satisfied. These are the three categories, but I cannot meet 10,000 employees of the company. So I go for a sampling, 50%, I look at the departments in the company. So I say that, okay, I will draw a sample. Say I will take, in my sample, I will create 100. My sample size is 100. Population size is 10,000. Sample size is 100. But out of those 100, 50% of the people I will select from the engineering department. So practical, कैसे sample बनाया जाता है, how sample is designed. Practically, I'm just trying to show an example. Sales and marketing department, I will take 25%. admin, I'll take 15%. That means out of 100 people in the sample, 50 will be selected randomly from the engineering department, 25 will be drawn from the sales and marketing, 15% will come from admin, and the remaining 10% will be part of the management, usual management cadre. So this is a way in which I create a sample of 10, but keeping in mind that we have proper weightage and all major departments are involved. But if I select entire 100 people only from the engineering department, it will become biased. If I select 100 employees, only those employees who are age-wise very senior, it will be biased. If I select 100 employees who are only from admin and management and who are below 30 years, it will become biased. So I hope you're able to understand how to design the sample so that it is ideally should be a probability-based sampling technique. And of course, as you can see, I was discussing about systematic sampling where I was selecting the initial starting point. We have taken the example of today's date and we arrived at the number 22. And then, of course, we saw that we are getting the starting point 22 and selecting every nth item. That means here k or n is 10. So every 10. So we will select 22, then 32, then 42, and so on. Here also you can see in this diagram which comes up on the slide, you can see we have a population of 500 and we are taking n as 3, yani starting point as 3, and then we are taking the k value of 10. So in my example, I took the starting point 22, random number, designed. How did I arrive at the random number? Those of you who are following, you saw I just added the digits of today's date, 22, and then we had a k value of 10. So my sample was 22, 32, 42, 52, and so on. In this example, you can see n is 3, starting point is 3, k value is 10. So the numbers or the items which will be selected in the sample, the third item, the 13th, 23rd, 33rd, and so on. So this is an example of systematic sampling. Then we see the other types, and you can see here one more example of stratified random sampling. Population, say, is 30% male, 70% female. We are getting a sample of 100 people. We are randomly choosing males from the population of all males, and separately we are choosing the females, and we are arriving at the sample of 100 people. Another example, say audit clients. We are creating strata. MNC companies, listed public sector companies, unlisted public companies, and private companies. These are the different strata. From each of the strata, we will select sample. So this gives you a stratified sampling. Right. Finally, we see multi-stage or cluster sampling. That means here I was talking about an example. So like you can use a multi-stage cluster like 5 states and 6 districts and then 4 villages. You can create clusters. And finally, we have purposive or judgmental sampling. This is non-probability. Like I mentioned about, say, out of those, say, 50 students, I already know there are 15 people or 20 people out of those 50 students who are very bright. They are toppers. They get very good marks. Out of those 15 students who usually get very high marks, I select 10. They are super performers. They're way above the average. Will I get the real figure if I ask those out of 15 toppers in that class? 15 toppers, I mean to say, who are scoring more than, say, 85, 90% as per their track record. If I select a sample of 10 students out of those 15 high performers, and for each of the 10 students, I get the marks, I average it up, will it give me the representative average of the entire class? No, not at all. It will be biased on the upper side. So this could be an example of a judgmental sampling. So non-probability sampling. So judgmental purposive sampling. Sometimes a sample is based on experience, judgment, or knowledge of a group, or simple bias. So this could be an example of a purposive sampling or a judgmental sampling. So this is the last type of sampling. Please remember, judgmental purposive sampling is non-probability based. It is not a random sampling. It is not an example of SRS. It is not simple random sampling. It is non-probability based sampling. It has its own subjectivity and a higher level of bias, estimation bias. With that, we move to the last part and we see the exercise on the statistical description of data. We first take the questions from some of the important questions from the study material exercise. 49th question, please see diagrammatic representation of the cumulative frequency distribution. We know cumulative frequency distribution, it is done through ogive. So option number B is the right answer. Next, we have question number 50. Please see the slide. For the overlapping classes 0 to 10, 10 to 20, 20 to 30, the class mark of 0 to 10 is what? Well, the class mark we know is the midpoint. So since these are overlapping 0 to 10, 10 to 20, that means the class limits and the class boundaries are equal. Therefore, the class mark is 0 plus 10 divided by 2, that is 5. Question number 50, option 1, option A. 51st question, for the non-overlapping classes 0 to 19, 20 to 39. So these are non-overlapping. So first we have to make them continuous. So the first will become 0 to 19.5. Then we have 19.5 to 39.5. In this way, we will find that for the class mark for 0 to 19, you will get 9.5 as the right answer. 52nd question also for the class 20 to 30, what is the cumulative frequency? 0 to 10 is 5, 10 to 20 is 8, 20 to 30 is 15. What is the cumulative frequency? So cumulative frequency for 20 to 30 is how much? We add up all the frequencies of the earlier classes plus the frequency of the particular class. इसका मतलब है 5 plus 8 plus 15. So we are getting 28. Option D, therefore, is the right answer. 53rd question, an ogive can be prepared in how many ways? 2 ways, less than or more than time. 54th, the curve obtaining by joining the points whose x coordinates are the upper limit of the class interval and y coordinates are corresponding cumulative frequencies is called what? Well, this is a curve by joining the points whose x coordinates are the upper limits of the class intervals and y coordinates are the corresponding cumulative frequency. Cumulative frequency means it is ogive. 54th question, option A. 55th question, the breadth of the rectangle is equal to the length of the class interval in what? So, histogram. Next, we have 56th. In histogram, the classes are taken what? Are they overlapping, non-overlapping? So, these are overlapping, continuous. 57th question, for overlapping class intervals, the class limit and the class boundaries are what? 57th question, overlapping class intervals, the class limit and the class boundary will be same. 58th question, we have for overlapping class intervals, or this is done 58th, data classification. So please see on the right hand side, once again for your kind reference, 58th question, data classification is done in 4 ways. We discussed it in the very beginning of our session today. Chronological or time series, geographical, qualitative, and quantitative. 4 ways. But presentation of data can be done in 3 ways. Textual, tabular, and diagrammatic. Please remember this difference. We come to the set B questions. Question number 2. Please see the second question, students. A sample study of the people of an area revealed that total number of women were 40%, percentage of coffee drinkers were 45 as a whole, and the percentage of male coffee drinkers was 20. What was the percentage of female non-coffee drinkers? Everything is on 100%, so we will take total number of people 100. Out of that, coffee drinker, Male is how much? 20%. So we are getting 20. So female has to be 45 minus 20, which is 25. Then we go to non-coffee drinkers. So non-coffee drinkers, male, how much are we getting? So coffee drinkers, non-coffee drinkers, please see, we are getting 60 minus 20 male, because we have seen that in case of the coffee drinkers, we have already seen that we have male percentage coming to 20. And we know the total number of male is 60. Women is 40, total number of male is 60. So therefore, out of 60 men, 20 are drinking coffee. So non-coffee drinker will be 60 minus 20, that is 40. And therefore, we get the final answer. Non-coffee, female non-coffee drinkers will be 55 minus 40. Why? Because we have seen the gender ratio and we have seen that coffee drinkers is 45. So non-coffee drinker will be 55. Out of 55, male drinkers are 40. Therefore, female non-coffee drinkers will be 55 minus 40, which is 15. Question number 6. You can see here, question number 6. The following data relate to marks of a group of students. You can see below 10, below 20, below 30. How many students got marks more than 30? If you see total number of students here, we see is below 50 is 100. And the question is, how many students got marks more than 30? You have 100 students getting below 50 and you have 65 students getting below 30. That means 100 minus 65, that is 35 students have scored more than 30. So more than 30, below 50, the score is 35. The 7th question, we can see, find the value of the observation between 250 and 300. This is also fairly easy. You can see this question. We have more than, question is, find the number of observations between 250 and 300. You have more than 250 is 38. More than 300 is 15. Therefore, between 250 and 300, it is 38 minus 15, which gives us 23. So option B is the right answer. Question 7 also we have solved. Now we see the MTP. So we have done a marathon session where we have covered 2 of the most important units, the first 2 units of chapter 13, and entire chapter 13 is getting completed already. We see the MTP question. Question 18 comes up. Median of a distribution can be obtained from which? We have already discussed ogive gives us the median, because the less than and the more than ogive curve will intersect like this, the less than, more than. So the point of intersection, if you extend it on the x-axis, you get the median. So question 18, option C is the right answer. 20th question, for open-end classification. So you have classes 0 to 10, 10 to 20, or 5 to 10, 10 to 15, so on. And the last class is open-ended. That means, say 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 and above. Please note, we are not writing 50 to 60. We are saying 50 and above. So this is what? This is simply an open-end classification. So which measure will be the best? You will later see median is the best, because median deals with only 50%, the middle marks. So they are not bothered about the extremes. So therefore, median will be the right answer. This was question 20 of the MTP. We now move to the next one, the RTP questions. The last 2 slides we are taking up now. The entire upper part of a table, we discussed threadbare each parts of the table. You may remember we talked and explained caption, box head, stub and body. Entire upper part of a table is known as the box head, option C. 20th question, a qualitative characteristic is known as what? Well, this is known as an attribute. Okay, so qualitative characteristic, like, say for example, the country of residence, the favorite subject, hair color. Okay, so say for example, the gender. This is qualitative, so therefore it will be seen as attribute. 22nd question. Please see, these are all RTP questions, very important. And ogive can be prepared in how many ways? We know less than and more than types, so 2 ways. So you have the options 19C, then you have 20A and 22A. We look at the RTP 62nd question. The dash, the size of the sample, more reliable is the result. I have discussed through different examples, practical examples, that the larger the size of the sample, the more reliability increases with the size. Reliability increases with the accuracy increases with the size. And sometimes you will see that if it is seen that the sample size and sometimes the sample size is directly proportional to the population size. This is called Bowman's classification. And there is yet another classification where we will see that the sample size depends on the population size as well as the population standard deviation. So there are 2 types of classification there. We will see that. Now we come to the next question. We have 63rd question. The standard deviation of the dash distribution is called standard error. Standard error is shown by the formula sigma by square root of small n, where sigma is the population standard deviation and n, small n, is the size of the sample. This is basically the sampling distribution. So 63rd question, option D is the right answer. We just check whether we have answered it correctly. 62C, 63D. Now we proceed to the last 2 slides and we see the past year's exam questions. So we have done the entire unit 1 and 2 in full details, followed by important questions from the exercise, MTP, RTP. Finally, we are taking up the past year exam questions. You can see number 4, frequency density of a class interval. We discussed both the frequency density and the relative frequency. So you can see frequency density means the frequency of that class divided by the corresponding class length. So option B. 34th question, the diagrammatic representation of the cumulative frequency distribution. Very important for your study. It is the ogive. Please remember, ogive is the graphical representation of the cumulative frequency distribution, plus from the ogive we can get the median, and of course ogive can be drawn in 2 ways, less than type and more than type. We proceed to the next question, number 73, on dash, the frequency starting from a rather low value. Here, please remember, we discussed about the frequency curve, which is the limiting form of the frequency polygon. It's a freehand curve, smooth, freehand, no edges, no jagged corners. So you see it starts from a low value and then reaches the maximum value and then gradually decreases. What does it mean? It increases slowly, reaches maximum. So draw it in front of you, do the mapping. It starts from here, increases, goes to the maximum, then again comes down. Well, I get a bell-shaped curve. Later on, you will see it is the shape of the normal distribution, bell-shaped curve. 73 is bell-shaped. Lastly, we look at a few other questions on sampling now. Number 12, from the study material exercise, a measure of precision obtained by sampling is given by what? Well, sampling precision is given by standard error. No question about it. Number 13, as the sample size increases, standard error will what? It will decrease. Standard error will decrease because if you see the formula, sigma by square root of n, as n increases, the denominator increases. It's a fraction. So therefore, the fraction becomes smaller and smaller. Sample size increasing, standard error will decrease. Question number 14. From a population of 25 members, random sample is drawn without replacement. It's a case of without replacement, SRS WOR. Question number 14. So this is a pure case of combination. So you have learned a lot about permutation and combination in the earlier session. This is a direct application of combination. 25C2. It comes to 300. Question number 15. A population comprises 5 members. The numbers of all possible samples of size 2 which can be drawn. Well, If you just think conceptually, I will create a sample of 2. I have a population of size 5 and it is SRSWR, simple random sampling with replacement, which means it's a simple case of permutation. I am drawing a sample of 2 out of a size of 5 and it's with replacement. So for the 2 member in the sample, first member I can select in how many ways? 5 ways. It's with replacement. So therefore, the second member also I can select in 5 ways. So it's 5 square, which is 25. Option number D is the right answer. We see the past year's exam question for Unit 2 on sampling. 32nd question, which of the following sampling method is completely free from sampling bias? Yes, undoubtedly, we will say it is the random sampling where there is absolutely zero bias. We move to the next one, 33rd question. This type of sampling method depends entirely on the judgment. So judgment or purpose, it is purposive sampling. So 33rd question in the past year exam, question 33, option C is the right answer. Finally, we have the 72nd question, according to dash. Please remember, we discussed about all the 4 laws, the 4 principles: statistical regularity, inertia, optimization, and validity. Question is, if a sample of a fairly large size drawn from the population, then on an average, the sample would possess the population features or the characteristics. Well, it follows naturally, seamlessly from the first principle law of statistical regularity. Option C, therefore, we will tick as the right answer. The last question, 74th question, in the stratified sampling, when the strata variances differ significantly amongst themselves, then we recourse to Neyman's allocation. In case of, there are 2, Bowley's allocation and Neyman's allocation. Now, there in the first case, sample size is proportional to sample standard deviation. But in case of Neyman's allocation, where the strata are varying, so here the sample size is proportional both to the population size as well as to the population SD. So the nearest would be, the most important feature is that the case of Neyman's allocation, sample size has to be proportional to the population standard deviation. So we will go for the second option. And with this, we come to the end of Chapter 13, Unit 1 and 2, and we are looking quickly at the summary, checking whether we have completed detailed discussion on each of them. Yes, summary, statistics. Please see the objective. It is concerned with quantitative data. Theory we have covered. Primary, secondary data we have discussed in detail. We have explained textual presentation, tabular and diagrammatic. Please go through the practical illustrations which we have covered in each of them so that you get a deeper understanding. Then we moved on to the next part on diagrammatic, and there we have discussed about line diagram. Please remember, the original name of line diagram was histogram. Now, of course, we use the term line diagram more frequently. Bar diagram, we have seen both horizontal and vertical, finally pie chart. And then last, we have discussed about frequency distribution, how we create frequency table and cumulative frequency. Finally, we look at the next part, the histogram, frequency polygon we have discussed. Please remember frequency curve, which is the limiting case of a histogram, and frequency polygon. Please do remember, you can pause the video later on when I was explaining that part. Please remember why I was discussing why the frequency curve is a limiting factor or a limiting form of the histogram and the frequency polygon. Finally, an in-depth discussion into ogive, an important part of our curriculum in this chapter. Coming to sampling, yes, first we have talked about the introduction, the need, practical illustrations, why we need sampling. I was referring to auditing and how we use samples. I also referred to the ICAI standard on auditing, the SA 530. Then we have discussed about the types of population characteristics, which is parameter, and the sample characteristic, which is statistic. We have explained and gone through sampling distribution. What is sampling error? The formula for sampling error. And from the formula, it follows that as the sample size increases, therefore, the sample size increasing, standard error decreasing, inversely proportional. Then we discussed about the statistical method of sampling, the non-statistical, simple random sampling with replacement, without replacement. We covered standard error calculation, and finally covered the systematic sampling, multi-stage, and finally purposive sampling. At the end, we have done a number of questions from the exercises, both for Unit 1 and Unit 2, and additionally, important questions from the MTP, both for the statistical description of data and for sampling. At the end, we have completed with RTP questions and the past year's exam questions. So that brings us to the end of Chapter 13, Unit 1 and Unit 2, Statistical Description of Data and Sampling. Please go through the video once again. Please pause wherever you feel you need to understand deeper and you want to go through the explanation once again. Please do that. Go through the questions which we have solved today. See the logic, see the rationale we have used, and please study the particular chapter once again from the ICAI study material so that you have a yet more robust understanding. Prepare yourself slowly as we move on in the next class onto the measures of central tendency. We have 2 sessions on that, part 1 and part 2. So I hope you have enjoyed the session, learned at least some useful tools and techniques, and hopefully you have a better interest in statistics now that we have started with the journey. So with that, we end the session. Thank you for your participation, dear students. Hope to see you in the next day. Till then, keep practicing. Thank you once again. I request tech support team to please conclude the session, sir. Okay, thank you, sir. Thank you.